Hi everyone, so in this video we are briefly going to be talking about a application of exponential functions. In particular, we're going to be talking about compound interest. So in general, compound interest means that if you have $100 in, say, a savings account, and let's say that every year that account grows by 10%. Then after the first year, you would have $110 because you would add 10% of that, which is 10, and you get $110. Now, so far, that's just like simple interest. What makes it compound interest is the next year, you don't take 10% of the original 100, you take 10% of whatever is in there currently. So currently we have $110. That means we're going to be adding $11 that second year. So you'd end up with $121. And then it would keep going. You would, for the next year, add $12.10. We'd be at $133.10, and so on. So the amount of interest you're earning is actually increasing every time because the balance in the account is increasing every time. That's compound interest. Now, there's two types that we're going to talk about right now. There's going to be what I usually call compounded n times. And I usually call it that because there's an n in the formula. So for this formula, it's going to say something like compounded monthly, or compounded weekly, or yearly. It's going to say a specific unit of time that it compounds. All right, so for this, we're going to have A, which is your accumulated balance, which basically just means it's your ending amount. So that's how much is going to be in the account at the very end of this time frame. You have P, which is your principal. That's your starting amount. That's how much is in the account at the beginning. R is your rate. So if, for example, it is 5% interest, then R would be 0.05. I say 0.05 because for these formulas, you need R to be a decimal. It cannot be in a percentage. So whatever percent you're given, just make sure that you change it into a decimal before you start trying to plug it into the formula. Next, T is the time in years. Then there's N. N is based on this word. So if we said compounded monthly, N would be 12 because there's 12 months in a year. If we said compounded daily, it'd be 365 because there's 365 days in a year. And so on. N is just the number of times that interest is compounded in 1 year, so it's based off of that word. Here's the most common ones, but technically you could also have other ones, like you could have compounded every 4 months, which would mean N is 3, because 4 months can fit inside of a year 3 times. Or you could have hourly, or you could have compounded every minute or every second. And for those, N would be really big numbers, right? Which brings us to our second formula. N could keep getting bigger and bigger and bigger if you just keep picking smaller and smaller units of time. So again, if we picked seconds, N would be really big because there's a lot of seconds in a year, right? Well, if you keep making N get bigger and bigger and bigger, eventually we get a different formula out of it. We get one that doesn't have N in it anymore because we just assume N is as big as possible. and we get this new formula. A, P, R, and T are the same ones from the first formula. So nothing new there. The difference is that E. So E is just a constant. So kind of like pi, everybody knows, pi is about 3.14 blah, blah, blah. E is another constant. It just represents a number. E is about 2.72 if we round it. All right, so it's just a number. Your calculator should have an E button, so your calculator knows what to do with E. So it's not something that you have to really worry about, right? But know that it is a number. It's not a variable, so you don't have to actually plug anything into E. You're just going to be taking that E and putting it into your calculator instead. Okay, so let's go ahead and look at example 1. So if a savings account was opened with $12,000 at an annual interest rate of 5.2% compounded quarterly 6 years ago, how much is the account worth now? And how much interest was earned? Okay, so let's focus on that first question. How much is the account worth now? So we see that it says compounded quarterly. So automatically, as soon as we see compounded quarterly, we know it's going to be the A equals P times 1 plus R over N to the NT. We know it's going to be that formula. Right? So if we want to grab all of these pieces, I'm just going to write all of these variables down so we can find them. So A is the amount that we end with. Well, if we're trying to figure out how much is the account worth now, that just means that we don't know A. That's what we're trying to figure out. So A is just going to stay A. P is how much we start with. That's the 12,000. R is our interest rate. It says 5.2%, so don't forget, we got to move the decimal 2 places to the left to turn it into a decimal. So it's going to be 0.052. N is based on how many times it's compounded. So it says compounded quarterly. Quarterly is 4 times a year. So N is 4. Then T is how many years. It said 6 years, so we know that's 6. So we're just going to plug all of this in. So we know A equals 12,000 times 1 plus 0.052 over 4 raised to the 4 times 6. The good news is we don't have to solve for anything here. Like A is already solved for, it's on the side by itself, so you just get to plug all of this into your calculator. Right? Now, one word of caution, and this does not apply to every calculator. It does depend on the type of calculator you have, but especially for some older calculators, or for ones that may not be as fancy as, newer graphing calculators, for that exponent, you may have to put it in parentheses for it to come out with the right answer. All right? If whenever you're plugging into your calculator, it gives you a number, and then as soon as you hit the exponent button, which should look like a little caret, if it gives you like a blinking box up here, and it's specifically letting you put stuff into that box, you won't have to worry about those parentheses. But if whenever you're doing this, you plug in all of that stuff, you hit the caret, and it just shows a caret, then the 4 times 6 needs to be in parentheses, otherwise your calculator will not realize that all of that's supposed to be an exponent. Again, that's completely dependent on what kind of calculator you have, but if you get the wrong answer for these first few, make sure you put parentheses around it because that's a very common error. Okay, so with that said, if you put this into your calculator, you should get that A equals $16,360.93 if we round it to the nearest cent. That's the answer to our first question. How much is the account worth now? It's that $16,360.93. Okay, for the second part of the question though, how much interest was earned? Okay, for that one, well, we know how much was at the end. We know how much was at the beginning. So the amount of interest earned is just going to be your ending amount minus however much you put in at the beginning. So in our case, it's going to be $16,360.93 minus the $12,000 that we put in. So we get $4,360.93. That's how much interest was earned. All right, so we're going to do this again. And in fact, for examples 2, 3, and 4, we're going to use the same problem, right? The only thing that we are changing is instead of quarterly, we are going to make it compounded monthly, weekly, and daily. And for example 5, we are also going to use the same thing, and we're going to make that one compounded continuously, right? So it's still $12,000. It's still 5.2%. It is still 6 years. We're just changing the quarterly to, in example 2, monthly. So again, if we go ahead and put all of our variables out, we start with 12,000. R is 0.052. This time our N, since it's monthly, is going to be 12. And our time is still 6 years. So let's go ahead and plug this one in. So we have A equals 12,000 times 1 plus 0.052 over 12 raised to the 12 times 6. Again, you get to plug this whole thing into your calculator, and if you do that, you should be getting $16,382.81 approximately. Again, to find out how much interest was earned, we are just going to take our ending amount, so $16,382.81, and subtract this $12,000 that we started with. If we subtract those, then we're going to be getting $4,382.81 in interest. All right, example 3 and example 4 follow the exact same pattern. You're just changing N. So weekly, well, there's 52 weeks in a year, so N would be 52. Daily, 365 days a year, so N is 365. So go ahead and try to plug those in. I will give you a few seconds to pause the video, that way you can try them. And then in a few more seconds, I will have the answers pop up just so you can make sure to check your work and make sure that you're plugging these into your calculator correctly. All right, so pause the video if you need to, otherwise they're about to pop up. All right, and here are the answers for 3 and 4. Again, the only thing you're doing is you're changing that n with 52 or the n with 365. All right, now if we go on to number 5, this one is going to be a little different because we're going to have to use a different formula. So as soon as you see that word continuously, that means we are now going to be using the A equals PE to the RT. We're using this formula now. All right, so no n is necessary for this formula. So we just need those other 4 variables, which again, we're using the same values as we have been. And we're just going to plug them into this formula now. So we have A equals 12,000 e to the 0.052 times 6. And again, you get to plug this straight into your calculator. Now, most calculators should have an E button at least, if not an E to the X button. If you are using a TI-83 or TI-84, you can find the EDX button above the LN button. So you'll see a button that says LN on the left side of the calculator. And you'll see a little blue E to the X above that. The E to the X being little in blue or little in yellow, might be a different color depending on which model you have. But that means that you have to press second to get to EDX. So you're just going to press second, and then LN, and that gives you E to the X. So it's going to give you E with a power already being raised on it. Right? So go ahead and try to put that in your calculator. And if you do, you should be getting approximately $16,393.86. All right, again, if we want interest, there's no difference in how interest is calculated, so we're still just going to be doing the 16,393 minus the 12,000 that we started with, and so we should get $4,393.86 for our interest. Okay. With that, let's go ahead and try something a little different now. So example 6. If $25,000 is deposited into an account earning 8.5% interest compounded continuously, how much will be in the account in 30 years? So still same idea, just this time we're given different numbers. So first thing we look for is it says compounded continuously. As soon as we see the word continuously, we know we're using the A equals PE to the RT formula. So let's go ahead and list out our variables. So A is the amount that we end with. We don't know that again, so I'm going to put a question mark for now. P is how much we start with. It says we start with $25,000. R is the percentage of the interest, so it's 8.5% interest, which as a decimal is going to be 0.085. And T is the number of years, in this case it says 30 years. So let's plug everything in. We're going to have A equals 25,000 e to the 0.085 times 30. Again, go ahead and plug this into your calculator. And we should be getting $320,177 and about 59 cents. All right, which is a really big number. Keep in mind that was also over 30 years, and that's also 8.5% interest, which you're usually not going to find something like a savings account with that high of an interest. But if it were these percentages, then yeah, these grow really fast, because keep in mind, these are exponential functions, right? We're raising something to an exponent, which means it grows really fast. All right, let's go ahead and try one that we're actually gonna have to solve for something now. For this video, we're just gonna be solving for some very basic things, mainly just A and P. Later on, we're gonna talk about how to solve for some of the other variables, but we're gonna need to know another little piece to be able to solve for those. All right, so example 7, you put some money into an account that earns 7% interest compounded monthly. If you have $15,201.06 in the account at the end of 6 years, how much did you originally put in? All right, so this one says compounded monthly. As soon as we see monthly, we know it's going to be the formula with the N. So like always, I'm going to go ahead and just list all of these out, and we can find them in the problem. A is how much it is at the end, and in this case, that's what we're actually given. We're actually given that in the account at the end of 6 years, we have the $15,201 in it. Oops. So the $15,201.06 is going to be our A in this case, because it's how much is at the end. For P, that's how much we originally put in, which is what we're trying to find. So I'm going to put a question mark. All right, R is the percentage, but remember, as a decimal, so 0.07. N is going to be the number of times it compounds per year. It says monthly, so that's going to be 12. And lastly, T says 6 years, so T is going to be 6. All right, so if we go ahead and plug all this stuff in, we have $15,201.06 equals P times 1 plus 0.07 over 12 raised to the 12 times 6. All right, so here's the thing. We need to solve for P now. All right? Now, this is going to look weird, but in the end, if you have, let's say, 8 equals x times 2. To get rid of the times 2, we would just divide both sides by 2, right? And we'd get 4 equals x. Well, it may not be perfectly clear, but all of this is just a number. It's not a pretty number, but all of it is just a number, which means we have P times a number, which means we can just divide by all of that and it's solved for. So we're going to divide both sides by 1 plus 0.07 over 12 to the 12 times 6. And you can literally put all of that left-hand side into your calculator, and it's going to give you an answer. All right. Now, again, little word of caution for some older calculators. The denominator, you're going to want to put that entire denominator in parentheses. So the entire bottom of the fraction, put it in parentheses. Again, this isn't needed on every calculator, but to be safe, put the entire denominator in parentheses. That way your calculator knows exactly what you're trying to get it to do. All right, with that said, if we do put that in our calculator, the right-hand side literally just all cancels out, so we're left with P. And the left side is going to give us our answer, and in this case, it is $10,000 if we round it to the nearest cent. All right, so $10,000 is our answer. All right, we're going to do one more using that same idea of needing to solve for P. So you are saving up for a vacation that is going to cost you $7,000. If you want to take that vacation in 2 years, how much would you need to put in an account that earns 4.5% interest compounded continuously? Okay, so first word is continuously. So automatically, we know we're using this formula. So I'm going to go ahead and write down all of our variables. So A is how much at the end. We want 7,000 at the end of this. P is how much to put in now. We don't know. R is 4.5%, so 0.045. And T is the number of years it's going to be in there, in this case 2 years, because that's when we want to take the vacation. All right, so let's go ahead and plug all of that in. So we have 7,000 equals P E to the 0.045 times 2. Okay, exact same idea as number 7. We have P times something. So to get rid of that, we're going to divide both sides by it. All right, and again, we can just put this entire left side into the calculator, which is going to give you your answer. So go ahead and plug that into your calculator. Remember, it's second ln to get to the e to the x if you have a TI-83 or 84. So go ahead and put that in, see what you get. You should be getting $6,397.52 approximately. Alright, so that does it for our intro to some finance stuff. This is not all we are going to be doing with these equations. We are eventually going to be solving for some other stuff, but that won't be until after we learn a little bit more about exponential functions and in particular how to undo them. So with that said, that's all for this video, and I will see you in the next notes. Thank you.